Hi students, I'm Mrs. Claus's 17-year-old daughter, and today you're going to be doing lesson 13.4 and you're going to be learning area of polygons.
Awesome. So students, if you need to pause the video and get your book, we are going to be working from page 392, guided practice. So I'll see you in a minute. Okay, so we should be on pages 392, and today we are going to be covering area of polygons. The standard we're working from is G1. I can find the area of odd-shaped polygons. So I'm going to put this page under the document camera so we have a little bit more ability to draw on the shapes, and we will get started in just a moment. Okay, we are on page 392, and I've drawn part of number 1, question number 1. So take a look at that in your book. And I also wrote the question. It says, in the diagram, the area of the square is 1 square inch. So let's underline that. Always underline the important parts. 1 square inch. 2 diagonal segments divide the square into 4 equal-sized triangles. So we have 2 diagonal segments. 2 of these triangles are divided into smaller red and blue triangles. 2 more are divided into smaller red and blue triangles that have the same height and base length. Then we have to find the area of a red triangle. And you've got that in your book there. I'm going to actually draw that out. So I'd like to draw this step by step. So first of all, I have 1 square unit. So I'm going to go back up here. That means that each side is going to be 1 unit. If it's a square, all sides are equal. So each side is 1 square unit. And with geometry, again, it's really important to draw your pictures and label your sides. 1 square unit. Well, actually, it's just 1 unit. The whole area is the square unit. 1 unit and 1 unit. Area is in square units. Length is in just units, or centimeters or meters or inches, depending on what the unit of measure is. Now, if I look down here, it says 2 diagonal segments divide the square into 4 equal-sized triangles. So I'm going to take my ruler and I'm going to divide 2 diagonals. I'm going to draw 2 diagonals from corner to corner. A diagonal goes through the center of a shape from one corner to the opposite corner. So I have 2 of those. And as you notice, I now have 1, 2, 3, 4 triangles, correct? Now, how big of an area is this 1 triangle, or any 1 triangle? What is the area of that? Well, if the whole square is 1 square unit, how many triangles do we have? 1, 2, 3, 4. So if we've divided this into equal sizes, wouldn't you say that the area of 1 triangle is 1/4 of a square unit? Okay, keep going from there. Let's look down at our problem for a minute. 2 of these triangles are divided into smaller red and blue triangles. So 2 of these triangles, and let me look at the book here, what color they made red and blue. So 2 of these triangles. So there's 4, only 2 of them. So I am going to divide these 2 in half again. And the one that they colored red is this one. It's going to color over my number that I wrote in there. Okay, I'll just kind of keep it like that. Yeah, we'll just color over it. Okay, we knew that the whole triangle here was 1/4. of a square unit. So we'll put that back. This whole thing here was 1/4 of a square unit because it divided into 4 equal sized triangles. Just want to kind of get that in there. The other triangle on the picture was colored in blue. And I think the other side, the same thing is happening. We've got a red one and a blue one. You're welcome to try this at home and draw your own square and color it in like this if you'd like. So now if I go back down here, it says 2 of the triangles are divided into smaller red and blue triangles. We just did that. That have the same height and base length. Find the area of a red triangle. Well, if we know that this whole triangle is 1/4, what would half of 1/4 be? Think about that. What is half of 1/4? Well, half of 1/4 is 1/8 square unit. Right? Half of 1/4 is 1/8. If you don't believe me, you could do the math for that and divide 1/4 in half. So divide 1/4 by 2 and see what you get using your knowledge of fractions. Okay, that was question number 1. Now I'm going to go on to question number 2. Got that here. Pull this one out and put this one in its place. Question number 2 looks like this. So again, we're still on page 392. So here's question number 2. So what we need to do is find the area of this whole thing. Now, at first I was thinking I could divide these into 2 rectangles, but the issue becomes, I don't know the size of this, do I? There's nothing to tell me the size of this little part. So I can't do that. So instead, what I'm going to do is I'm going to make it into a whole big rectangle. And now I can find the area of the large rectangle. So area of large rectangle. And by large rectangle, I mean the whole thing, this whole thing, if this were a rectangle. So remember, the area of a rectangle is the same as the area of a parallelogram, base times height. Or now we'll use length times width. Doesn't matter, length times width, base times height, same thing. So what is our length? Well, our length or our base is 18 times our width or our height is 14. So then you can go ahead and do the math and multiply 18 times 14 on your paper, and you should get 252 feet squared. The little 2, because we're talking about how many squares 1 foot by 1 foot will fit inside this surface. So we're not done because we don't need the area of the whole thing, do we? We need the area of just this part. So now what I'm going to do is find the area of the imaginary orange one. So if you think about it, if I subtract out the area of the whole thing minus the area of this part, won't I have just this part left? Exactly. So let's find the area of, we'll call it the imaginary rectangle. Imaginary rectangle. So the area of that is going to be length times width or base times height. We'll do base times height this time, just so you get used to both formulas. What is the base of this? How can I find that out? Well, I know the whole thing is 18, and if I trace up, I know this part is 4. So if this whole thing here is 18 as well, I've used 4 of it, what's going to be left? Well, it's going to be 18 minus the 4. That's going to be my base. Let's move this up a little so you can see. Okay. And my height. What is going to be the height of this? Well, we know that the whole thing, let me get this up here. The whole thing is 14. This part is 10, right? So the height of the imaginary rectangle is just 10. So now we should be able to calculate that out. 18 minus 4, 17, 16, 15, 14. 14 times 10. Any number times 10, you can do the math, is just the number 14 with a 0 after it. So 140 feet squared. Now, if we subtract out the area of the whole rectangle minus the area of the imaginary rectangle, that should give us just this part, just the blue part. So 252 minus 140. 2 minus 0 is 2. 5 minus 4 is 1. 2 minus 1 is 1. So the answer is the area of this blue part is 112 feet squared. That is the answer to number 2. If you need to pause the video to get that down, go right ahead. It will not be in the notes that I share with you because we're doing it under the dot camera. So it would be great to pause the video and get the notes down on that. Okay, I'm going to move on then to number 3 on page 292. You need to find the area of this shape. So we know that the area of a rectangle is base times height, or length times width. So let's find the area of, I'm going to try to make that, it's supposed to be of the whole rectangle, just like we did in the last problem. So we have a base of 20 times a height. Be careful on this. The height is not that, because that's short, right? The height is that. So the area of the whole rectangle, so let's put whole rectangle. The area of the whole rectangle then is 220 and then a 0. You can go ahead and do the math on your paper at home. Focus that a little better. Okay, now we have to subtract out, what do you think? Yeah, this little piece. We want to get that piece out of there. So we got to figure out the area of that triangle. So area of imaginary triangle. And I just want to label this. This is 200 meters squared. So the area of the imaginary triangle. What's the area formula for a triangle? Move down just a little, move up. Area is equal to 1/2 base times height. Okay. So if we call this our base and we call this our height, how can we find the base? What is that? It's not labeled. How can we figure it out? Well, we know that this side is 10, and we know that this part is 8, and we know the whole thing also has to be 10 because it's a rectangle and opposite sides are the same length. So what would that be? Exactly. It would be 10 minus the 8, right? So I'm going to rewrite that as 10 minus the 8. 1/2 is still there. 10 minus 8 is our base. What about our height? Let's go back up. This is our height. How do we figure that out? Well, we know this whole thing is 20, and we know this bar is 16. So what does that have to be? Exactly. 20 minus the 16 that has already been used. There we go. So now we put our calculations together. We have 1/2. 10 minus 8 is 2. 20 minus 16 is 4. And now I just multiply all of that together. So it's really the same as 1/2 times 2 over 1 times 4 over 1. So these 2's will cross off. They cancel. And I'm left with just 1 times 4 on top. These are going to become 1's. And 1 times 1 on the bottom. So my answer then is 1 times 4 is 4. 1 times 1 is 1. Any number over 1 is really just the number. I'm not done. I have just found the area of this tiny little triangle up here. What I need is the area of this blue shape. I've also found the area of the whole rectangle. So we'll circle that. And I found the area of that tiny triangle. Now I need to subtract out the whole rectangle minus the tiny triangle. So you could just count backwards in your head. 199, 198, 197, 196. Or you could subtract. You can't take 4 from 0. You have to borrow way up here with the 1. The end 1 becomes 10, and the other zeros become 9. 10 minus 4 is 6. 9 minus nothing is 9. 1 minus nothing is 1. So 196 meters squared is your answer for number 3. Okay, go ahead and pause the video if needed to get that down. And then we're going to move on to number 4. Here is number 4. We have a lovely little arrow here. And we need to find the area of this shape. Well, I'm going to split this shape into 2 pieces, because I think I have enough information to be able to find the area of this rectangle and the area of this triangle, and this time add the 2 areas together. So let's find the area of the rectangle. What would be the area of the rectangle? The area of the rectangle is going to be base times height. Our base here is the same as this side. So 18 times, what's our height? 10. So 18 times 10 is 180 feet squared. And now I need to find the area of our triangle piece. So the area of the triangle is 1/2 base times height. So that's 1/2. What is the base? Well, we're going to use this as our base. So we know that this orange piece is 10 because this is 10. Opposite sides of a rectangle are equal in length. This is 5 and that's 5. So we have 10 plus 5 plus 5 for our base. And our height is this piece right here. So how are we going to figure out this piece? Well, we know the whole thing is 24 feet, and we know this part is 18 up to here. So if we subtract 24 minus 18, that'll give us the piece that's left. So 24 minus 18. Okay, So now we have 1/2 times 10 plus 5 plus 5. That's going to be 20. And we have 24 minus 18. That should give you 6. And then you're going to multiply across. So let's move down a little. 1/2 times 20 over 1 times 6 over 1. Can we cancel anything? Yeah, there's a couple things we could cancel. I'm going to use a different color just to highlight that. 2 will go into 20 10 times. 2 will go into itself once. So I'm left with 1 times 10 times 6 on top, and 1 times 1 times 1 on the bottom. That gives me 60 over 1, which then is just 60 feet squared. I'm not done yet. Remember, I have to go back and add the area of the rectangle and the triangle together. So I have 180 to add to 60. So 180 plus 60 is 0. 8 and 6 is 14. Carry the 1. 240 feet squared is my answer. Go ahead and pause the video if you need to, and then we'll continue. Okay, we're back here in my virtual library, and I want to share my screen with you and show you. Here's the problems we just did. You should have been filling them out in your math book as we went. And question number 5, how can you find the area of a polygon that is not one for which you know the area formula? And to get that, you can just divide the weird, W-E-I, shape into familiar shapes that you already know the formula for, right? Divide the weird shape into familiar shapes you already know the area formula for. You could also add on to make a large shape like we did on numbers 1 and number 2. So those are a couple ways, and then you would subtract out the other piece. So now our homework then is going to be review the guided practice, page 392, the one we just did. Make sure you understand that. And then we also should complete pages 393 and 394. Let me bring up 393 here for a minute. I got to flip it, rotate it. Okay, 393, and I want to erase this. All right. So if I bring this up, and let's make it a little bigger. Number 8, I wanted to point out to you, you have some missing corners, and they want to know the area of this tabletop. So you're going to have to, let me draw a little line here. You're going to have to extend out, oops, undo. You're going to have to extend out the rectangle all the way across and all the way down. Like that. Move that one up a little bit. So about like that. So you're going to have to find the area of the whole thing. And then you're going to have to subtract out each corner. And then letter B is saying one of the students wants to make a tabletop shape like a right triangle. So a right triangle looks like, draw that actually. A right triangle is one in which you have a right angle. I can make this work exactly or close to right. So you have a right angle right here. Okay, so that's the kind of shape they're asking for. What are a set of possible lengths for the sides of the tabletop that meet in a right angle? So you're going to have to, you already know the area, so you're going to find the area of this weird shape, right? And once you get that, you're going to set that equal to, so you're going to set the area of the tabletop equal to 1/2 base times height. And then you're going to have to move the 1/2 to the other side and double it, and then figure out two numbers that will equal that answer. So if that's confusing for you, when we meet online live, we can go over that problem. So I hope you have a good day or night whenever you're watching this, and we will be back together soon. And bye. See you next time.